Yes, thank you. Good evening to all of you.
Yes, sir.
And friends, here, how to start the 6.2 now. 6.2 is regarding increasing and decreasing functions. Increasing and decreasing functions. See, we understand what is an increasing function and what is a decreasing function. See, when I say as x increases, the simple logic is that we take the question like this, straight line you take. This is an increasing function, no doubt. Right? It is an increasing function. How do you know such an increasing function? Now, as x increases, this is our definition. As x increases, y also increases, then we call the function is increasing function. This is the basic thing what we know from the ages now. Okay? As x increases, y also increases. So, good evening, dear. Welcome to the class. We are waiting for you, Siddharth. Right, yes. Let us look at this now first. 6.2 increasing and decreasing functions. Suppose if I take a straight line, yes, straight line, you know very clearly that this is called 2 and this is called 3. This is x equal to 2 and x equal to 3. Yes. And say this is called 2 and this is called 3. And now okay, f of x. This is called y equal to x minus a. Okay? When x equal to 2, y is 2. When x equal to 3, y is also 3. Is it not as x is increasing from 2 to 3, x is increasing from 2 to 3, y is also increasing from 2 to 3. Then what do I conclude from this? It is an increasing function. Okay, this is fantastic. Very good. This is how they started the definition of increasing and decreasing functions. What they said is f of x is a function in an interval AB. Let us make interval AB. In an interval AB. Here, you take two numbers in A and B interval, say some x1 and x2. If x1 is less than x2, yes, if x1 is less than x2, same thing, again I'll repeat, I am putting a different little bit of spice, I am putting it, then it appears a different order, nothing else, the same thing there. X1 is less than x2, then f of x1 is also less than f of x2. Or less than or equal to f of x2, doesn't matter. If this is the case, we say it is an increasing function. Whereas if x1 is less than x2 and f of x1 is strictly less than f of x2, then it is called strictly increasing function. This is the difference. Now, I will give you a graphical example. You understand what is the difference between the increasing and strictly increasing functions. Yeah. Friends, suppose if I take a function like this, something like this, this is strictly increasing function. Strictly increasing function. This is called strictly decreasing function now. Strictly decreasing function. Then what is increasing and what is decreasing function means? This is a increasing equal increasing. Right? So it is an increasing function. Not strictly like this. Okay? It's always increasing. This is increasing, constant, and then increasing. That's why it's called just increasing function. This is strictly increasing function, strictly decreasing function. This is called increasing, simply increasing function. Otherwise, you can see like this. How do you say this? Just reverse it. Strictly decreasing function. Somewhere, right? Decreasing. So this constant has to come on. I hope it's clear. Increasing, decreasing, strictly decreasing, strictly increasing. Now the graphs are given in the textbook here. Go through it, fabulous one. Same case now for decreasing, you can write here yes or minus. Nothing to remember here. Same symbol should be followed now. Less than one. This is just equal, no, not equal. No, that's strictly. This is called strictly, and this is called increasing. That's it. So this is same category mark. They follow same increasing means what? They follow the same pattern of signs. Mean inequality mark. Less than here. Whereas if you want to go for increasing, then this is less than that. This should be greater than or equal to. This is called decreasing function. Less than, again, this should be greater. That is called strictly decreasing function. That's it. That's it. Okay? This is our style as transformed, our knowing is again re-explained here in terms of functions. Earlier we used to speak something like a linear function y equal to x, y equal to x square. அது வந்து இப்போ வந்து ஃபங்க்ஷனா மாத்திட்டாங்க நம்ம we have to say in terms of x and f of x. Okay, the same thing. This philosophy is followed here. This logic is followed. Same logic is here. Next is for straight lines and all is okay. To say that the function is increasing or decreasing, we can say. A straight line is very simple. For complex curves, it's very difficult to say just by following this technique. For complex functions, graphs very difficult. How to say whether the function is decreasing or increasing in the interval? Yes. Friends, here you take this function, straight line with the just take this one also. Yeah, this is a parabola. Say y is x square or f of x equal to x square. You take a x1 and x2 mark. Okay, x1 equal to 2 and x2 equal to 3. And this is called f of 2. And this is called f of 3. Okay. So what is f? 2 is less than 3 ds. And what is f of 2 mark? F of 2 is 4. And f of 3 is what mark? 9. So 2 is less than 3 implies 4 is less than 9. That's called x1 is less than x2. F of x1 is less than f of x2. We say that the function left side of the right side of horizon is an increasing function. So we can say that from O to the right of O, yes, to the right of O, the right of horizon, yes, we can say the function is increasing. Yes or no? Yes. Please say my yes or no.
Yes, sir.
Yeah. This is number one point. Yes. We are very clear, Mark, with this numbers. I hope it's very clear. X1 is less than X2. F of X1 is less than F of X2. Okay. So it's strictly increasing, no doubt. Because it's not equal, okay? So F of X1 is less than F of X2, so strictly increasing. Friends, same thing, my dears. Okay, same thing, sir. To the right of left of this one, you take the 2 points here. This is called X1 and X2. Okay, X1 and X2. X1 equal to -1, X2 equal to -2. Whatever. Okay. Now you can say that second one. Okay, I will write here. Please follow me. X1. This is X1. This is X2. Can you say X1 is less than or X1 is more than X2 mark? -1 is more than -2, yes. Just put f of x1 mark. F of x1 equal to 1 ds. F of x1 is 1 mark. That is f of -1 is 1 because 1 square, right? Yes or no? F of x2 is nothing but x2 square. X2 is nothing but -2. That's called f of -2 is nothing but 4 mark. So you are telling that -1 is greater than -2, whereas 1 is less than 4 in the greater symbol, in the lesser symbol, far DS. The same symbols, same symbol should be there for increasing, different symbol should be there for decreasing, my dears. Karma. Same symbols, less and less, less and less. Here, greater and less are lesser and greater. However, they should have different signs. They should have different signs. Karma. They should have a different signs. Greater, lesser. Here, lesser, or greater. Same inequalities, same type of inequality. For increasing function, for decreasing function, for increasing function, same type of inequality. For decreasing function, opposite type, okay? Different type, opposite type. Different inequalities. Same inequalities and different same inequalities. And here, different inequalities. Okay? Am I meaningful or not?
Sir, is this the case always or just in this case? Like this, it'll be minus for decreasing functions and positive for increasing functions. The same sign, basically. Is it always like this in all cases, or?
No, this is just foundation I'm doing. I'm coming now. Your point, I'm coming now. You are just ahead of it. Just I'm coming to that point, okay? You're right. I'm coming to that. Suppose, if I take a point here, draw a tangent, and just measure this angle from the x-axis. This is measured in the anti-clock theta here. Can you say theta is acute or obtuse, ma?
Acute.
Acute. Acute. If theta is acute, my dears, what is tan theta, ma? Tan theta is positive or negative, dears?
Positive.
Positive. That means m is slope. Slope is tan theta, dears. Slope. That means slope is positive. We already told dy by dx, slope and dy by dx, ma. That is called f dash x, ma. Yes. If f dash x is positive, it is an increasing function with this logic, my dears. Puriyudha, clear?
Yes, sir.
Same way you draw a tangent here, this side. Tell me, you are measuring from the positive x-axis, ma. Positive x-axis anti-clockwise. This is the angle, dears. Tangent is making anti-clockwise. This is theta. Tell me, is theta is acute or obtuse, ma?
Obtuse.
Obtuse. So theta 1, theta 2, dears. Theta 2 is obtuse. Tan theta 2 is what, ma? Negative. Slope is negative, ma. Slope and dy by dx or f dash x, ma. So f dash x is negative, dears. F dash x is negative means what, ma? F dash x is less than 0. And here f dash x is positive means f dash x is greater than 0, ma. This is an increasing function. This is a decreasing function, dears. So now you can also have our second model, ma. Second model for increasing function, strictly increasing or increasing function, f dash x is greater than 0. இது வந்து if x1 is less than x2, greater than x2, f of x1 is, yes, just let me state, which implies if x1 is greater than x2, f of x1 is less than f of x2. This is called a strictly decreasing function. Okay? That's one definition. Another definition, what is second definition? In terms of derivatives, tell me, f dash x is less than 0. Positive slope, increasing function. Negative slope, decreasing function. Yes, that's all. Yes, that's all. Note Panikoppa, please. See, we said f dash x is greater than 0 here. Positive. F dash x is less than 0. What if, number 1, f dash x is greater than 0. Number 2, f dash x is less than 0. Number 3, f dash x equal to 0. What is the derivative of a constant function? 0. Therefore, the function is a constant. The function is decreasing function. The function is increasing function. My equal one. Yes. This is enough now. Constant. The derivative of constant is what? 0. That means the function should be a constant, right? Is it clear?
Sir, could you tell the constant thing again? The constant thing. How is the constant function is constant? How are you telling that it's constant?
The function is a constant means the derivative is what? 0, right? So the function is a constant means it's a line like this.
Right, sir. Yeah, I got it now.
Y equal to 2, y equal to 3, or f of x equal to 2. Okay?
Yes, sir.
Constant function. Therefore, it's neither, it is a constant function. That means what? It's not increasing nor it's a constant function, man. Okay? It's not increasing. There are functions, okay? If I say, schema please, if I just to a function of right? Now, how I conclude here must, let us say this one, okay, 0 and 2 minus 2. I can say 0 to 2 ds. I can say the function is increasing. Function is strictly increasing. Adhe madri 0 and minus 2 mark. The function is strictly decreasing. The interval is very important. Is it okay?
Yes, sir.
Right, yes. Let's move on to some question more, please. Let us take one question and see how it is. How can you establish that in the strictly increasing function? Please take the question here. One example number 8. Show that the function f given by f of x equals to, yes.
I can't see the top of the board, sir.
I didn't get you.
Can't see the full board, sir. I can't see the top of the board.
Okay, got it. Thank you. Right, I have shown that the function f is given by f of x equals to f of x equals to x cube minus 3x square plus 4x, and x belongs to R. Okay, x belongs to R, the real numbers for us. Is strictly increasing in R. Friends, here we have been told that if I can say that f dash x is always greater than 0, then it is strictly increasing, right? And f of x is given. If you want to show that the function is strictly increasing in R, it is required to prove that f dash x is more than 0. Do you agree?
Yes, sir.
Therefore, you find f dash x now. That's it. 3x square. 3x cube by differentiation, 3x square minus 6x and plus 4 minus. Please take 3 common, yes. Take 3 common, x square minus 2x. Okay, this I can write, hold on. This I can write 3x square minus 6x plus 3 plus 1. Do you agree?
Yes, sir.
Yeah. Friends, if that is the case, can I take 3 common across? Yes? Sir, what is this? Why are you doing like this, sir? How do I know? See, my dear friends, the logic here is, if I write something like x plus 2 whole square, it is always greater than or equal to 0. Please understand this, please. If I have x plus 2 whole square plus 1, definitely it is greater than 0. Please. Try to understand now. Something like x square is greater than or equal to 0. X square plus 1 is always greater than 0. This is what you need to understand here. Purida?
Yes, sir.
So with this logic, I am trying to write in the model. I try in the model. This is square number, 3 into x plus 1 whole square plus 1. See the minimum case now. This is the minimum value of this one is what? 0, correct? The square number,
Yes,
the minimum value, square, the minimum value is 0 and above. So it's a 0. But what about this one? Plus 1. So it's always greater than 0. Do you agree, ma?
Yes, sir.
Say like this. We know that 3 into x plus 1 whole square is greater than or equal to 0. 3 into x plus 1 whole square plus 1 is greater than 0. Therefore, f dash x is more than 0, which implies the function is quickly increasing. Siddharth, are you clear, ma?
Yes, sir.
Siddharth,
Sure. Yes, sir.
are you listening to that?
Yes, sir.
Are you watching Siddharth? Okay. Yes, sound no different over.
Yes, sir. Yes, sir.
Right. Okay. No, you are not responding, Siddharth.
No, sir. Just my mic issues.
Yeah. Okay, dear. Okay. Just watch here. Please just look at this. How
Yes, sir.
beautiful question is it? This is called f of x, ma. Okay? We will do the f dash x. Why? Because we are required to prove that f dash x is positive. Therefore, it's a duty for us now to differentiate f of x. This I am splitting 3 plus 1. This I can take 3 common. This is nothing but x plus 1 whole square, ma. X a square plus b square plus 2ab. This minimum value, see this. Take this. We know that 3 into x plus 1 whole square greater than 0. Add 1 per it becomes greater than 0. Therefore, f dash x is greater than 0, which implies the function is increasing. Come on, take it, yes. Take it for completely. Take it. I'll wait for it. Okay, boss. Shall I rub it now? Right. I just give you one question, ma. You please try it and tell me. So I'm giving. Yes. In the question, in the model பாருங்க. Second model பாருங்க. Model example 9 part. Model example 9. Prove that the function given by f of x is equal to cos x is a strictly increasing in interval 0, 5, 0, 5. B strictly decreasing in interval pi comma 2 pi. C. Neither increasing nor decreasing 0 to 2 pi. இதெல்லாம் தேவையில்லை நம்ம we can easily tell from the see f of x is cos x ma. F of x is cos x is a function. Mathematical program, just think about this now. This is called cos function now. This is called minus 90, 0, 90. This is called 180 and this is called 270. So, please. From here to here, from 0 to 180, is it increasing or decreasing function?
Decreasing, sir.
Cos function only. Yeah, f of x equal to cos x. Yeah. Strictly decreasing in 0 to pi. Sorry. Strictly decreasing in 0 to pi and strictly increasing in pi to 2 pi and neither increasing nor decreasing in 0 to 2 pi. Okay. Okay. Just watch here, my dears. Is it from 0 to 180? You tell me, is it decreasing or increasing now?
Decreasing, sir.
Decreasing. That's over. Then pi to 2 pi. This is called pi. This is 2 pi. Pi to 2 pi is continuously increasing or not? Yes or no?
Yes, sir.
That's if you know the graph, you don't require all your mathematics now. You don't require mathematics. You don't require any type of math, any kind of mathematics. You see the figure. Decreasing up to 180. From 180 it is increasing up to 360. But if you click overall 0 to 360 or 0 to 2 pi, it's a both, right? Neither increasing, you can't claim from 0 to 2 pi. If you take full interval, you cannot claim that it's increasing in from 0 to 2 pi altogether. You can't say. That's why it is neither increasing nor decreasing. Okay, this is to understand. If you know the graph now, the whole issue has come here now. We don't know the graphs of many functions. That's why you require this mathematics. The graph is there, it's a visual display. Where is the question point? You can say it. Therefore, there's no need of any mathematics. The issue is here. Most of us, we can't visualize the mathematics of the graph. I heard one of the saints was telling that all your music is a geometry, it seems. All our music, okay, everything is a geometry. Everything is a geometry, he says. Everything is geometry, it seems. So that visualization, the graphical understanding of everything, anything is a very critical part of success in life. Hence here, so the graph I am able to say it, but he is expecting us to do mathematically. Mathematically, now we know that if f dash x equal to 0, less than 0, decreasing. If f dash x is more than 0, is increasing. Okay? Right, let us see now, friends, here. F of x is given as cos x dx. Okay, let us see the solution now. Graphical part is very, very clear now for us. Let's say if f of x equal to cos x, what is f dash x now? Minus sin x. Now let us consider 0 to pi. 0 to pi, it is in second quadrant mark. It is in first to second mark. First and second mark. Yes or no, yes?
Yes, sir.
The interval is from 0 to pi means what? First and second it pervades. Friends, first and second quadrant may sign is positive here. Sign is positive. Do you agree, Mark? All first quadrant. All means everybody is positive. Second quadrant sign is positive. Therefore, first and second sign is positive. This is positive and this is negative here. Negative into positive is what, Mark? Negative, Mark. F dash x is negative. That means f dash x is less than 0. Therefore, it is strictly decreasing from 0 to pi ds. 0 to pi. Am I clear?
Yes, sir.
Yeah. Now, friends, coming to pi to 2 pi mark. Pi to 2 pi if I take, again f dash x equals to minus sin x. Interval is pi to 2 pi and now it spreads from third and fourth quadrant mark. Third and fourth quadrant, sin x is negative mark. Sin x is negative mark. Yes, sir, Papa. All silver teeth. Sinada ruling is over here and here. Sin ruling is over, and now sin is negative, negative. Therefore, sin x is negative. Yes. F dash x is minus sin x. Sin x is negative mark. Negative into negative and a positive mark. F dash x is positive. Yes. Which implies f dash x is greater than 0. That means it increasing. Yes. Do you agree?
Yes, sir.
Do you agree? Yes.
Yes, sir.
Yes. Therefore, in the interval pass it, this also pass. But what about the 0 to 2 pi mark? 0 to 2 pi level, you can't say that it's a negative. You can say negative, you can say positive mark. Because overall, you can't say it's a negative or positive from 0 to 2 pi. Hence, it is neither increasing nor decreasing. Next, third case mark. This is the first case, yes. This is second case mark. Third case now. Third case. See. Third case. See, what is the third case now? F dash x equal to minus sin x. Sin x is neither positive nor negative. Therefore, minus sin x is neither positive nor negative. Hence, f of x is neither increasing nor decreasing like this. I hope it is clear, okay?
Sir, I have a question, sir.
Yeah.
Why? I mean, it's more like it's either positive or negative. So why are we saying neither? Because it can be either positive or negative, right, sir?
See, the issue here is, Mr. Arpit, can you say outrightly it is positive? No.
No, sir.
Can you say outright it is negative? No. That's why I am saying it. There's nothing wrong. Okay, it's English only. Whatever it is not strictly positive. It is not strictly negative. Correct?
Yes, sir.
That's what I mean by here. Okay. So sin x is neither positive nor negative. Throughout the interval, it is neither. It takes neither side. It doesn't take particular side, okay? It won't take, I'm positive, you can't say. I'm negative, you can't say. Therefore, it is neither positive nor negative, okay?
Yes, sir.
Right. Therefore, it's neither increasing nor decreasing. What a beautiful question, dear. So, this particular thing requires one more class, ma. Such a beautiful one. And 6.3 also you require 2 classes, 6.2 also 2 classes, 6.5 also 2 classes, and 6.4 1 class is enough. இன்னொரு மாடல் இருக்கப்பா, அந்த மாடல் பண்ணிட்டு நான் இஸ் a trigonometric question. இன்னொரு மாடல் இருக்குது, அந்த மாடல் பண்றேன். You take this one, take this. Right. Please move on to the next one. Yes. That's another ultimate model is coming up now. It's a brilliant model. That's the culmination of this chapter. That's the end of me. Once you learn that model, it's ultimate model. As that model comes for 4 mark or 3 mark, a bit longer type question. Right. Right. Yes. Yes. Look at one more question. Now this is the question. This is the model which we are interested in. Please let us take it. This again I am doing a one example. Kindly for each chapter or each exercise, do the word examples so that you get a complete idea about the methodology, structure, how the textbook is following, and how the teacher is doing. There will be some difference between the teacher and this, but anyway, there won't be a big difference. Only English, maybe I may be writing we know that as WKT and they write we know that completely. Okay. Sometimes they also follow the same thing. No big difference will be there. But if you see both, you can easily understand, the gaps between the teaching as well as teaching and the textbook. You could easily verify it. Please. Then finally, you will understand that there's no big difference here. Both are looking alike and புரியுது. So நீங்க பண்ணணும், please word examples பண்ணுங்க please. Now word example number 10. This is the ultimate one, please. This is the model which is a very, very familiar for 4 marks. You can write down that 4 marks question. Okay. Nowadays, everything is changed. We can't say it's maybe for 5 marks. Earlier, there was a 6 mark. 6 is gone. Yeah, 6 is there. I can still, it's there. 5 marks. No, it's 5 mark. 1, 2, 3, 4, 5 mark. In the 4 mark question, they have given case study question. Case study question is an amazing type of a question. Because 11th standard is not strictly, we didn't follow the board because it's no board at all. But 11th standard, 12th standard, they have given this case study questions, the revelation. I tell you, such a brilliant type of questioning. There you have to understand the concept. You don't know from which topic they ask. And all are broken into MCQs. Okay. 5 MCQs are given for 4 marks. You need to answer any 4 marks, any 4. Only any 4 marks. The problem is some people answer all 5 questions. Nothing wrong if you answer all 5 questions. They take only first 4 answers only. Ninga 4 edutala, but any 4 you can write it. The case study and the super on our technique to really squeeze the students, okay, really whether you are understanding or not. See, the new education policy is coming up. Yesterday, day before yesterday, I think Prime Minister was addressing the educationist after 1 year completion of NEP. That's a new education policy. they are bringing lots of changes into probing the mind of a student. Please. Otherwise, there's no point in learning or what to say, rote learning. Okay, that has to be not only rote learning. Even the MCQs were not serving the purpose, serving the purpose, but the great extent you can check the child mathematical ability. Real life application question solve the case study question is the classic case. That we will see that. Okay, these are the chapters which are familiar for case study questions. Is application of derivative. Number one, always one question will be there. Application of derivative, lot of scope for case study questions. Or 4 mark kandipa varum paidrunga edukana idula vandu application is there. That's why the one question will come. Next chapter only 2 questions mark, 4 marks will be there. Most likely one is application of derivatives, that's the 6th chapter, and the other chapter is the 13th chapter, that's a probability mark. Every topic is having eligibility, but these 2 topics are more, what to say, likely to come. Is heavy probability for both of them to have a case study question. These kind of applications are many in the probability, and the pair itself is application of derivative. So real-time applications are there. So you will have a question from these 2 majorly, my dears. Right. Even matrices, one more topic. So in the 3 matrices, the 4th and 5th chapter, 4th chapter rather, 4th chapter. Third determinants is 4th chapter. Yeah. So these are the 3 chapters familiar for case study questions. Note pankonga. Definitely, if you prepare, one more chapter is called linear programming problem. Idiyum varala. This is last. This is called 11th or 12th chapter. 12th chapter, I think. 12th chapter. LPP. Out of 4, definitely 2 will be taken. In the 4 chapter, you can super then only you can attempt your case study questions. Right. Friends, let us see the last model. Last model, find the intervals in which the function f find the intervals in which the function is given by f of x equals to f of x equal to 4x square, x square minus 4x plus 6 is a strictly increasing, b strictly decreasing. That's all. These are the 2 questions. Yes, the function is this. You need to find out in which interval it is strictly increasing and in which interval it is strictly decreasing, my dears. Find the intervals, find the interval. And the interval is just like we said earlier, f of x equal to cos x, right? Is decreasing in 0 to 2 pi, 0 to pi, strictly decreasing, strictly pi to 2 pi, and of course from 0 to 2 pi it is neither increasing nor decreasing. Okay, right. So in the same manner as a trigonometric function, that's why the interval is an angle. Now it's the algebraic function, the interval is the real numbers. Okay, right. So friends, here, first of all, what we shall do is for the strictly increasing and strictly decreasing, we all know that f dash x is more than 0 and f dash x is less than 0. Therefore, the basic need is that we have to find out f dash x. So, what is f dash x, my dear, please? Are you all listening, ma? Are you watching and listening, please, Siddharth and Arpit?
Yes, sir.
Right. F dash x is 2x minus 4 pa. What I will tell you is equate it to 0 so that you can find out the values of x ma. This is only to find the values of x. This is only to find the turning point. We will see what is the turning point and all. Okay, I'll tell you. 2x minus 4 equal to 0. 2x equal to 4. Which implies x equal to 2. Friends, you take a number line like this, put x equal to 2 here, formula. So x equal to 2 ma. Now this whole number line is divided into two intervals ma. One is called minus infinity to 2 from here to here. Other one is 2 to infinity ma. This is the first interval. Interval 1 and interval 2 is what? Yes, 2 to infinity ma. You can friends, are you clear ma? This one with this turning point here. Here, two upper manda it's a one behavior. Before 2 is one behavior. After 2 is another behavior. That's the turning point. Do you agree with me? If before is decreasing, after is increasing, that's turning point where at 2 is a turning point. So to find turning points, please equate it to 0 mark. To find the turning points. Like then we have done already like this mark. Please. At x equal to 0 is the turning point. My x square f of x. F dash x is 2x. 2x equal to 0, that's called x equal to 0. So to find turning points, we equate it to 0 ds. Note down this point. 2x equal to 4 and x equal to 2, x equal to turning point here. And friends, here minus infinity 2 in 2 to infinity, these are the two intervals. What I am going to do is now you write down this interval 1, that's called minus infinity to 2. And another interval is 2 to infinite. This is the interval ma. This is the interval. The intervals are nothing but what ma? X values ma. These are the x values ma. X belongs to 2 to infinity and x belongs to minus. Yes or no? These are the x values only. You take one sample value for x ma. Sample of x. Between minus infinity 2 to minus infinity, I can take 0 is one sample value, dears, correct? 3 is one sample value I can take. Yes or no? Say yes or no. Are you listening or not? Yeah, please.
Yes, sir.
Yeah. So take x equal to 0, my dear. And take x equal to 3. Sample of x. என்ன சொல்ல வரேன்னா இந்த இன்டர்வல்ல வந்து ஃபுல்லா ஒரே பிஹேவியர் இருக்கும்பா. That's the reason. Any value you take at that point, if you can say f dash x is, now take f dash x. What is f dash x mark? 2x minus 4. Or you can write 2 into, you can also write 2 into x minus 2 pa. Okay? Better, correct? However, doesn't matter. Okay? Put x equal to 0 here. Put x equal to 0 here. Find out f dash x. F dash x is minus 4. Negative. Okay? Negative. One more column, please write it. One more column, please write it. This is called nature. What is the nature, ma? Less than f dash x is less than 0 means what? Strictly decreasing. Next one, f dash x you find out at x equal to 3. X equal to 3, you put it here. 3 2s are 6 minus 4 is 2. 2 is more than 0. Strictly increasing. Therefore, this is the interval for strictly increasing is this. This is for decreasing one. That's all, yes. That's all, yes. See how beautiful it is. The making this table. After, once you find the turning point, this is called turning point mark. Okay? At 2 it's turning. See, sir, this is called y equal to x square. What about the graph of this? Yes, you can draw it, ma. You can draw it something like this, ma. Both roots are positive, yes, here. You get something like this, ma. It cuts the x-axis at 2 points, ma. In the graph. Note panikopa, please. This is the interval, sample of x, f dash x. Based on f dash x, you should say nature of the function. Nature of the function. See, this is, I think, actually, the graph is not like this. I'll tell you what is the correct shape of the graph. Okay. F of x equal to, Siddharth, are you listening?
Yes, sir.
See, in the x square minus 4x plus 6, you write x square minus 4x plus 4 plus 2. Can I write this is x minus 2 whole square plus 2, ma? This is the thing, ma. This is the thing, ma. This is the graph, ma. From 2 it starts, ma. Anything, put x equal to 2, 0. So y f of x equal to 2, ma. 2 and above, ma. It's always more than 2, ma. The minimum value of the function is 2. That's why 2 and above, and at x equal to 2, it is 2, ma. This is called 2, ma. This is the turning point, ma. Wow, what a thing, ma. What a thing. 2 is the minimum, and at 2 is the turning. Aha, what a brilliant question, ma. This is the graph of this function here. GeoGebra poi paranga, you will get like this, ma. Please. நீங்களே பாருங்க இப்ப 2 to infinity பா 2 to infinity இப்படி போங்க 2 to infinity போனா is it increasing or not பாருங்க and 2 to minus infinity it is decreasing my friend. Minus infinity to 2 வந்து decreasing function minus infinity to 2 minus infinity இருந்தா 2 க்கு வந்தா it is a decreasing function for this. Yes or no? Yes.
Yes, sir.
That's all. Yes, I think we have done all the 3 models for tomorrow. We will do tomorrow class. I will keep it, or else we will just take this question for. See this graph also very interesting. Tomorrow we will discuss. Okay, a few more questions on Monday, or if possible tomorrow. I don't think you will be liking for a class. Okay. Anyway, if you like it, I will conduct. I don't have any problem. Okay. Right. Yes. Thank you very much, ma. We'll see tomorrow. Siddharth, try to pull some more guys here.
Yes, sir.
Our class should grow. I am very happy that you have come. I don't know, nobody is daring to join my classes from that. But you are the one gem of a student for me. That's more than enough. You are equivalent to the whole class. I know that you are a tremendous boy. You have tremendous potential. That's more than enough for me. We can produce a centum, or if not centum also, you can do very, very greatly in the class. But it's a wrong time for you. I don't know how you are enjoying that. How about physics and chemistry, pa?
Good, sir.
Physics and chemistry. They are good. Okay. So you are attending both, ma? You are attending JEE as well as NCRT or only NCRT?
Only NCRT, sir.
Oh, but how many of them joined for JEE, pa? I think they have said it is a must for everybody.
No, sir. No, sir.
No, it's only those who are interested.
Yes, sir.
Okay. Number students have joined Pandrikangla for JEE.
Yes, sir. 12 members, sir.
Oh, 12 members are there. Okay. யார் அது இவங்க இருப்பாங்க மோஸ்ட்லி யாரு யாருப்பா அவங்க 3 பேர் 4 பேர் இருக்காங்க இல்லையா ஆல்ரெடி those girls 2 girls and 2
Yes,
or
sir.
3
Yes,
girls are there. Okay. In addition to that, even our boys, anybody has joined?
Srihari is in NEET, sir.
Srihari is neat, of
Srihari.
course. I know.
Yes, sir.
இல்ல இல்ல
Then
there
Jai
was
Aditya.
யாருப்பா?
Jai Aditya.
Jayaditya. ஆமா Jayaditya and Akshaya and Pavitra and some girls were there, right? 2-3 girls were there.
Yes, sir.
Okay, those 3 and அவங்க தான் JEE NEET students அவங்க தானா?
Yes, sir.
நம்ம ஸ்டூடெண்ட்ஸ் யாரும் ஜாயின் பண்ணல. நம்ம 10th பேட்ச் இருக்கு இல்லையா, அந்த பேட்ச்ல யாரும் இல்லையா, யார்
No,
ஜாயின்
sir.
பண்ணல?
Madesh
No.
alone, sir. Madesh alone.
This is of course NEET, of course, right? So it stands. All our students they are not shifted from NCRT to JEE இல்லையா, அந்த மாதிரி கிடையாது, right?
Yes, sir.
Okay. Yeah, good. Nice part. Thank you very much, and we'll see tomorrow or day after Monday. I will tell you. I'll update you. Thank you very much. Keep working, Siddharth. Don't neglect, ma, please. This topic is very interesting here. Yeah. All the best, ma. Thank you very much.
Thank you, sir.